All right, so we have another short video here. We're going to go over some notes for experimental design. I'm going to share my desktop, and these are some old notes I have from years ago, but they will do us well here. So this has to do with experiments, experimental design. The difference between, first we want to define the difference between observational studies and experiments. An observational study is just what it says. You're observing something and gathering information. You are not changing anything about the situation. You are just observing and recording data. In an experiment, you are imposing some sort of condition or treatment on some of the individuals in the study. So we take a population of people and we break them into groups. We call this treatment groups. Some of the people have something imposed on them. Let's say it's a new drug and you're testing to see whether it's effective or not. So one of the groups receives the drug, another group receives a placebo. Placebo being, so everyone say, let's assume this is a drug trial, everybody gets a pill. They don't know whether the pill is the actual drug or just a sugar pill. Okay, that's called the control group gets the placebo. So treatment groups, there may be more than two. There could be one group getting a certain dose, second group getting a second dose, and a third group getting no dose, or more than that. But let's just keep it simple for now and say there's two groups of people. Now, the assignment to these groups, as we spoke of before, should be using simple random techniques. The idea, very important idea in experimental design, is to try to create groups such that everything about the groups are as similar as possible, other than the one thing that you're measuring. If that, and it's never going to be perfect, but if you can get as close as possible to having everything else the same between the two groups, other than the one thing you're measuring, then hopefully, with some sort of confidence, you can attribute those differences to that thing you're measuring, whether it be a drug treatment or whatever else it is. All right, so we have a group of people, we break them into groups. One group gets the treatment, one group does not get the treatment. Single and double blind refers to who is aware of which group is getting what. A single blind study means that the individuals in the study, remember individuals being people, places, or things, and I guess this would only apply to when they're people, they don't know if they've received the treatment or not. They don't. So in other words, they don't know if they're in the treatment group or if they're in the control group. A double blind study, but in a single blind, the experimenters know who has gotten the treatment and who hasn't. In a double blind study, neither the participants, the individuals, or the experimenters know which one is the treatment group and which one is the control group until obviously after the results are in, they will go back and see which was which. Okay, so experiments versus observations. And the things you want to notice about a statistical study are really common sense things. These are things, web pages you look at, stories you see in the news, based on studies. You want to ask yourself these questions, right? These are just kind of common sense things to think about when you're looking at some sort of statistical study, whether it be an observational study or an experiment. What's the goal of the study? What are they trying to show, right? What is going on? What population did they draw from? What is being measured? And what type of study? Is it an observational study or is it an experiment? Who's funding it, right? That's huge. That's always huge. Who's paying to have this study done? Because whoever's paying for it probably wants to see a certain result. So that introduces us to this idea of bias, right? And this goes back to splitting up the treatment groups evenly so that there's no differences among them. If the treatment group knew they were receiving the treatment, they might act a different way than if they don't, and vice versa with the control group. We want to eliminate bias as much as possible. It's never going to be perfect, but we try to eliminate bias as much as possible. The more we can eliminate bias, the more trustworthy and useful the results of any study will be. So selection bias, that goes back to assigning the individuals to the groups. Hopefully that was done in a random manner. Participation bias has to do with the individuals themselves. We want to at least make sure it's single blind, I would say, so that they don't know whether they received a treatment or not. Measurement bias has to do with what is being measured. Is it something that's easily measured? Is it a numerical quantity that can be measured down to any level of accuracy we wish? Or is it something, is it an emotional kind of measurement? Is it something being measured by people on a, excellent to poor scale or something like that? Is it difficult to measure? And very important is confounding variables. Confounding variables, sometimes known as lurking variables, are things that are going to affect the outcome of your study, but that were not considered. Right? And this is tough to control because sometimes you don't realize it until after the study's done. You might look at the results and go, wow, we got these results, and then realize that something else actually affected the study. So a famous example of this in some textbooks is a study that was done where green tea was brought to retirement homes, and it lifted the moods of the old folks at the retirement. So the study said green tea, good for people's moods. So this was the result of the study. But what wasn't mentioned is the green tea was served by like little children from the local schools. So quite possibly the old folks' moods were elevated just by having the little tykes running around in the old folks' home. So this is a good example of a confounding variable, something that affects the outcome of your study, but that you didn't allow for going in. All right, so those are the important things I want you to notice about experimental design. And we'll see you next time.